Section 5.6 is over rational functions. So a rational function is a function that has, or that is expressed as a fraction with a polynomial in the numerator and denominator. Okay, so for example, say f of x is a rational function. We have some p of x over some q of x, where each of those are polynomials. So we'll say this is a sub m, x to the m, all the way down to I sub naught, and then b sub n times x to the n, all the way down to b sub naught. Okay, so when you graph these guys, you'll see something happen. So like, let's say I go to graph this. You can put it in your calculator and check. When I go to graph this, at -1, we have something that kind of looks like this. Okay, that's what the graph kind of looks like. Right here, this is called an asymptote. Okay, this one's called a vertical asymptote. It's caused by a division by 0. So whenever we were first defining domain with these guys, we said that we couldn't divide by 0, so we know that this bottom part couldn't equal 0, so we said that x could not equal -1. Well, here's an example of why x not equal, what happens when x equals -1. On the graph, we have this jump, and that's called a vertical asymptote. So how do we find vertical asymptotes? Given f of x is some p of x over some q of x, the vertical asymptote is at the x values where the bottom part equals 0. Okay? Then we also have horizontal asymptotes. We'll do some examples here in a second. But we also have horizontal asymptotes. Okay, so we have some, this case is going to be some y value where they never actually touch it. So how do we find those? Well, this one's just kind of like a little classification chart. If we have something in standard form, so we'll say we have something in standard form, we'll agree that the top part is degree m, and the bottom part is degree n. So we have three possible things. That the degree of the top is less than the degree of the bottom. We have a horizontal asymptote at y equals 0. If m is equal to n, we have a horizontal asymptote at y equal to a sub m over b sub n, basically just the fraction formed by the lead coefficients. And our last possibility is if m is greater than n, then we have no horizontal asymptotes. So let's do some examples. We want to find all asymptotes. So let's say I have x plus 1 over 2x minus 1 times x plus 3. First off, here we have degree 1, and this one, it's not in standard form, but if you multiply it all out, it's degree 2. So let's first find vertical asymptotes. We got the bottom part set equal to 0. It's already in factor form, so it's fairly easy to solve. Here you get 2x equal to 1, or x equal to 1/2. Here we get negative 3. So we have two vertical asymptotes at x equal to 1/2 and x equal to negative 3. Horizontal asymptotes, we look at the degrees. You can see that the degree of the top is less than the degree of the bottom, and that tells us we have a horizontal asymptote at y equal to 0 if you go back and look at this. Okay, let's do another example. So we have f of x is equal to 2x plus 1 over x minus 3. On top, we have degree 1. On bottom, we have degree 1. So for vertical asymptote, we take the bottom, set it equal to 0, and we get x equal to 3. For horizontal asymptote, when m equals n, it's the fraction formed by the lead coefficients, which is 2 over a 1. So that's 2 over 1, or y equals 2 is our horizontal asymptote. And our last example here, we're going to have f of x equals x squared plus 1 over x minus 2. This is degree 2. This is degree 1. For vertical asymptote, take the bottom, set it equal to 0. And we get 2. For horizontal asymptotes, we have a degree of the top is greater than the degree of the bottom. If you go back to the chart that says there's no horizontal asymptotes. Okay, we'll stop there.